Hello everybody, welcome into another lesson. So today we're going to do the volume of pyramids, cones, and spheres. So here we have a square pyramid. A pyramid in general has only one base, unlike a prism which has two bases. A pyramid only has one. And just like a prism, your base could be anything. It could be a square, a rectangle, a triangle, a pentagon, what have you. Today we're just going to stick with square pyramids. We're just going to do that for the volume. Now, we got the volume here. The volume formula is 1/3 of the area of the base times the height. Well, why is it 1/3? Where does that 1/3 come from? The idea is that if you take pyramids and try to put them inside a prism, it would take 3 pyramids to fill that prism. So that's why a pyramid is 1/3 of the volume of a prism. So the volume is 1/3 the area of the base times the height. Well, that's the general formula, but we have a square pyramid. Well, we'll still have the 1/3, but the area of the base being the square, you just take a side squared, then you're just going to take that times the height. So that is the volume of a square pyramid, is 1/3 of a side of the square base squared times the height. So let's say we have the base of the square pyramid is 5 feet. The height has to come straight down from where all these sides meet at a point above the base down to the center of the base. That is the height. Let's say the height is 12 feet. Yeah, so the height will be 12 feet. We want to find the volume of this pyramid. So you'll take 1/3 times a side squared, which would be that 5 feet, raise that to the second power times the height of 12 feet. Okay? Well, then we still have 1/3 on the outside. 5 squared, that's 25. Feet squared, that is just that. It's going to be square feet times that height of 12 feet. Now all we got to do is take all this, put this in the calculator, and you'll have your answer, which I can tell you right now is going to be 100 cubic feet. When you multiply all these together, you're going to get a volume of 100 cubic feet for this square pyramid. I'll do 2 more examples with this pyramid. And then we will move on to a cone. Alright, let's say the height is 11 inches. Let's say the length of the square base is going to be 13 inches. Alright, so we got the volume of this. We want to find the volume. You'll take 1/3 times the length of the side of the base being 13 inches. You'll raise that to the second power times the height of 11 inches. Well, let's see. We got 13 squared, which would be 169. That'd be 169 inches to the second power is square inches. Take that times the height of 11 inches. Now we just got to do all the multiplication here, and we'll get the volume of the square pyramid. get about 619.67. So 619.67 cubic inches is what you would get. So the volume of this pyramid is about 619.67 cubic inches if we're rounding to 2 decimal places. I'll do one more example with the pyramid. So the pyramid again could be anything. It could be anything for your base. It could be a square, a rectangle, triangle, pentagon, what have you. But the formula, the overall formula is the same. It's 1/3 of the area of the base times the height. In this case, we have a square pyramid, so that area of the base is the side squared. So you just plug that in for the area of the base. You'll take 1/3 times the side squared times the height. That's how you get the formula for a square pyramid. Alright. Length is 25 meters for the pyramid. The height will be 20 meters. Alright, so the volume will be 1/3 times the side of the square squared. So it'll be 25 meters, that raised to the second power, times the height of 20 meters. So you still have 1/3. You do that 25 squared, you'll get 625. The meter squared is just that, it's square meters times that height of 20 meters. Now all we got to do is just take all this, multiply it together, and we'll have our volume of this square pyramid. Alright, so that's going to be about 4,166.67 square meters. Sorry, cubic meters, excuse me. The volume of this pyramid is about 4,166.67 cubic meters once you multiply all these together. So that's it for pyramids. I'm going to leave the overall volume formula up because for a cone it's the same. The overall volume is the same. Let's deal with a cone here. So a cone Alright. So we have a cone here. A cone is like a pyramid in the sense that it only has one base, but that base is a circle. That's what makes it a cone. The base is a circle. So the overall volume is going to be the same. It's 1/3 of the area of the base times the height. But that base is a circle. So the volume is going to be a little bit different than it would be a pyramid. The area of the base being a circle, the area of a circle is pi r squared. Then you have the height. So the volume of a cone is 1/3 pi r squared times h when you put in pi r squared for the area of the base being a circle. And it's the same idea as a pyramid. If you tried to put a cone into a cylinder, it would take 3 cones to fill that up, to fill that space. That's why it's 1/3. So you have, just like in a pyramid, you have your height from where all the face, where the circular faces meet at a point above the base, and where that point is comes straight down to the center of the circle. That's your height. Of course, we need to draw a radius on this circle. Let's say the radius is 3 yards. We have a radius of 3 yards for this cone. The height would be 21 yards. Alright, so we got the volume of this being 1/3 times pi times that radius of 3 yards to the second power times the height of 21 yards, which would still equal 1/3 times pi. Now 3 to the second power, that's 9. Yards to the second power, that makes it square yards, times the height of 21 yards. Now the commutative property of multiplication allows me to arrange these in any order. I'm going to take 1/3 times 9, that would give me 3 yards. Sometimes it helps to do that to get rid of that fraction if you're able. So if I take 1/3 times 9, that'll give me 3 yards, so I'll have pi times 3 yards squared times 21 yards. So again, the commutative property of multiplication allows me to arrange these here in any order. I could take 1/3 times that 9, and I could get rid of that 1/3, because 1/3 times 9 is 3. So you just have pi times 3 yards squared times 21 yards. I go ahead and multiply all those, I should get my volume of the cone. So pi times 3 times 21 gives me about 197.92. 197.92 cubic yards. So the volume of this cone is about 197.92 cubic yards. That's exactly what I would get for the volume of this particular cone. Alright, let's say the radius is 10 centimeters. The height's 30 centimeters. So, again, I have a cone with a radius of 10 centimeters, the height of 30 centimeters. So to find the volume, I'll take 1/3. Well, let's keep the pi where it belongs. 1/3 times pi times that radius of 10 centimeters. That 10 centimeters will be set to the second power, times the height of 30 centimeters. Alright, so we'll still have 1/3 times pi. Now that 10 centimeters squared, well, 10 squared is 100. Centimeters squared is square centimeters, times that height of 30 centimeters. Well, I'm going to pull the commutative property of of multiplication again. I can multiply these in any order now. Since I've done the exponents, I can multiply them in any order. I'm going to take 1/3 of 30. That would give me 10. So I'd be reduced to pi times 100 centimeters squared times 10 centimeters, because that 30 and 3 cancel out, giving you 10 centimeters. The 1/3's gone. I'm going to simplify this a bit further before I go on. I could take 100 times 10, which would give me pi times 100 times 10 is 1,000. Centimeters squared times centimeters would be cubic centimeters. So now I just got to multiply pi and 1,000, and then I'll have my volume. So let's go ahead and do that. Pi times 1,000. Give me 3,141.59. Cubic centimeters. So the volume of this particular cone is about 3,141.59 cubic centimeters. That's what I would get. And I'll do one more example for the cone, then we'll move on to spheres. Alright. Let's say the radius is going to be 27 meters. The height would be 50 meters. Alright, so I have a cone with a radius of 27 meters and a height of 50 meters. Well, to find the volume again, we'll take 1/3 times pi times that radius of 27 meters. We'll set that to the second power times the height of 50 meters. Well, let's see, we got 1/3 times pi. Now we need to figure out what 27 to the second power is. Not a pretty number, I'm sure. 27 times 27, it's 729. If I could write. Times, then we got the meters to the second power, that'd be square meters, times that height of 50 meters. Well, let's see. I can pull that commutative property of multiplication trick again. I can do 1/3 times 729. I can get rid of that 1/3 altogether. Let's find 729 divided by 3. That'd be 243. So 1/3 times 729, you would have 243. I still have that pi, but I would have 243 square meters times that height of 50 meters. Now this is much better to work with. All I got to do is take and multiply all these and I'll have my volume of the cone. So let's see, pi times 243 times 50 would give me 38,170.35. Cubic meters. So the volume of this particular cone is 38,170.35 cubic meters. So again, cones and pyramids both have the same overall volume formula. It's 1/3 times the area of the base times the height. But this is where you got to have a good grasp on 2D shapes and what the areas of different 2D shapes are. So it'd be 1/3 times the area of the base being a circle. That area of the base being the circle is pi r squared. You'll take 1/3 times pi r squared, then just times the height, h. That's where the formulas vary. But we're going to get into our last one here, called spheres. We will get into spheres. Okay, so let's deal with spheres. See, the volume of a sphere, there's really no way to help you remember it. You just got to kind of remember it. It's going to be 4/3 times pi r cubed. Alright, so we got ourselves a nice sphere. We got a sphere. So, biggest thing, you got to define your radius. That'll be your radius of the sphere. The volume is 4/3 times pi times the radius cubed. There's really no other way to remember it. Just have to remember it that way. So, let's say we had a radius of 3 feet. This sphere has a radius of 3 feet. Well, let's find the volume by taking 4/3 times pi times that radius of 3 feet set to the third power, which would be 4/3 times pi. Then we do the exponents, 3 to the third, that's 27, times feet to the third power, that's going to be cubic feet. Now all you got to do is take this and multiply it, you'll get your volume of the sphere. So let's go ahead and do just that. So let's do that, 4/3 times pi times 27 would give me about 113.1. So I get about 113.1 cubic feet. That would be the volume of the sphere, about 113.1 cubic feet if I had a radius of 3 feet. And I'll do 2 more examples with the sphere. Let's say I just have a radius of 5 meters. So this sphere has a radius of 5 meters. Well, let's take the volume formula. It'll be 4/3 times pi times that radius of 5 meters to the third power. So you'll still have 4/3 times pi, but that 5 to the third power, that's 125 times meters. Meters to the third power is, well, cubic meters. Now all you gotta do is your multiplication and you'll get the volume of the sphere. So let's see, 4 divided by 3, take that times pi times 125, you get about 523.6. So you get about 523.6 cubic meters for the volume of the sphere. 523.6 cubic meters once you've multiplied all those together. And I will do one more for the purposes of doing a sphere. Alright, let's say the radius is 10 inches. So the radius of this sphere is about 10 inches. Well, to find the volume, we'll still take 4/3 times pi times that radius of 10 inches set to the third power. Okay, so you'll still have 4/3 times pi, but that 10 to the third, that's 1,000 times your inches to the third, well, that'd be cubic inches. Now you gotta do is your multiplication and you have the answer to the volume of your sphere. So let's do 4/3 times pi times 1,000. You get about 4,188.79. So 4,188 188.79 cubic inches would be the volume of the sphere. Yes, 4,188.79 cubic inches is the volume of the sphere with a radius of 10 inches. So that's it for the volume segments. Next lesson, we're going to move into what's called surface area. Surface area is different from volume. Volume, of course, is how much space will fill the entire object. Whereas surface area is the coverage of the outside of the object. Like, for example, if you want to paint a box or paint a room or something, you're going to use surface area. You're not going to use the volume because that would be filling the room or filling that box with paint. No one fills a room with paint. So you're going to use surface area for that. So the particular surface areas we will cover in the next lesson are cubes, prisms, and cylinders. Yes, we will cover those. So I hope everyone has a good day. Take care.